Yeah, so in this video, I'm going to do actually an overview of the different areas, sections and subsections of the control center, just so you have a global understanding of how it works. So I was supposed to talk about your algorithm, but first just maybe get through this fast. So the first box that we see here, the motive tracking. So this is this tracks where the robots are. So we have yeah, just basically a small localization system here. This says where they are, what orientation they are, and here we clean up the information just so that it's I can move this. Oh, that was not intentional. Okay, so yeah, so this creates a bus with the motive data that we are going to use up here. Yeah, this creates threshold. I don't remember if this was one of the first things I did. Oh yeah, so it just makes sure that if it's below the threshold, we just have zeros. So otherwise, it was giving us messy data. So that's all it does. Okay, here we have the joystick and keyboard instructions. So yeah, we have here the different keys and what they do. I guess there's not that much to say about this. If you want to add keys, this is where you're going to do it. So you can just follow along and see how the other ones are done. And union model communication. So this again communicates with this, which should always be right. So yeah, it sends basically all the information that the union model needs to determine the perimeters of the moving obstacles, which are the other robots. So there's a few things that we decide here: the minimum distance, maximum distance, shift forward and shift left. So this sends it over to the union model here. This does the calculations. I won't go in there. So you see the interpreted MATLAB function. So actually this calls the get union matrix. Now this here, so we have the get union matrix somewhere in here, and the this uses nearly all of the other functions that are here to work. So it's a little complex. I won't get into that, but I tried to make the code as clear as possible. But if you have any questions, if you need to know, if you want to know, just ask. Then okay, let's go back into the control center. So the streaming data. So there is a continuous conversation that is happening between the control center, the union, and the robots. And so here is that conversation that's happening, basically. So as you can see, there are vectors and matrices that contain all the information. The union contour is sent from the other model to this one. That's a in this case, well, no, it's always 3008 by 6. So it's 3000, that can 3000, it's a vector of 3000 that contains the contour information, and the 8 others is just other information that is needed for it to work. Don't remember by heart, can look into it. Then you have the joystick instructions so that the robots know what's going on. The parameters, that's all the parameters that are set up there, and that's sent to the robots. You have the motive data, so that's the positions of the robots, and you have the targets. So yeah, so when we initialize, we assign them positions, so that's just a little script here that gives them their position. If you want to change the position, you can just the default positions, you can do it here. The fifth one here, I believe, slightly different. Okay, yeah, no, this is so yeah, this one actually when this is set up, so the default, it's going to follow the joystick in your hands. So if you do Control Alt 0, or when you run it initially, it's going to move towards the joystick, or if the cameras aren't detecting the joystick, it's going to move to the either 0 position or the last place it detected the joystick. So if you want to move around and have robots follow you in the room, you're going to put it at this setting. Otherwise, it goes into the 1 through 4, which are just different positions for which are assigned depending on the number of robots. Additional instructions. So these are things that I didn't initially predict. So every time I have something new, a new parameter I want to add, something, I add it in here. The order here is very important because we have a corresponding data bus here. It's color coded so that it's easy to follow, and these here, the index here, correspond to the index here, and so actually in this case there's this one, and so it's this one plus 37. That's written up here, plus 37, and it's also written here, so you can't forget it. And so if you want to add anything related to communication, if you want to add controls, if you want to just, yeah, controls, instructions, anything, this is where you do it. So you just do this one and keep going down and create a new layer, a new level every time you reach the next step. It's pretty, yeah, it's I tried to keep it as simple and straightforward as possible to prevent it from, because it can easily get very, very messy if you're not careful. So yeah. So yeah, this checks which agents are online at any given time. So when an agent is online, it broadcasts its ID, and so this picks up the ID. If the communication is working correctly, you can go back up here. When the agents are online, you will just see it being steady here. You'll see a 6x1 vector here, 1x6 vector here, and it'll be zeros for the ones that are offline, and the ID of the bot for the ones that are on. That's essential for it to work. If you see that the numbers are not steady, I said in the other video, but I'll really stress this, don't start them. Nothing's going to work. Just stop everything, reboot the like stop this, stop the robots, reboot the robots, start over. And yeah, you don't need to reboot the computer, but the robots will need to be rebooted, and this will need to be stopped and restarted. This here, so this streams data, all the data to the robots. So what we have here, so it opens up different ports. So in the first one here, we have the union data. So as you can see here, 17211, 17212, and we have here 17221, 17222. So when I was saying that the ID is central to how the system works, the last digit here corresponds to the ID of the robot. The last digit here corresponds to the ID of the robot. So everything comes back to that ID. So here you see that this is streaming the union. So the information is sent to the union model. The union model sends it back to the control center, and the control center sends it back to the robots, and the robots do the calculations for the path planning. And here, this is a little difficult to see, but we have all the data from the streaming here. So if we go here, we follow this. So it's this data that is there. So we have the joystick instructions, parameters, data, targets, and everything else is here. And then this, we make a matrix with it, or actually a bus with it, and then it's split here so that each robot only receives the information that it's allowed to receive. So bot number 1 does not know the actual position of bot number 2. It knows that there's a moving obstacle at that position, but it doesn't know that that obstacle is a robot. It knows that there's an obstacle because of the union data, but it doesn't know that it's a robot. And what else? Okay, so yes, so this is only enabled for the agents that are online. Otherwise, it's just a waste of resources. Okay, this creates the agency matrix. So nothing special here. I didn't create it exactly the way you did. So basically, my approach was more to create a backbone to assure that it's always connected, instead of randomly trying. So I don't check the eigenvalue, but I think you might want to add it just because I don't know why, but it will always be connected by the nature of the how I create it. So if an agent goes offline, it creates a new agency matrix that is connected. If an agent comes online, it creates a new agency matrix that is connected. Right now it's randomly connected. I think in your tests you might want to add an option here so that it's not randomly connected. And that will of course depend on the number of bots. Yeah, you can play around with that. This is where the agency matrix is created. And finally, we have the broadcast time activation delay. So this just sends the time for when from the moment the robots receive an instruction to the moment they act on it, so that they can be synchronized. Okay, the storage. So yeah, these are just all the variables in the system are here pretty much. The hosts, that's not really important. That's related to the keyboard and well, the speech recognition, which is actually not working because of an issue with Windows. But and yes, so I think we pretty much have seen a good overview of the control center. So in the next one, I will do an overview of the agent model. And then after that, we're going to see more specifically how all that combines together to make your algorithm work. So see you next video.